Math 70, section 9.5, we are going to add, subtract, and multiply radical expressions. In the previous section, we learned multiplication and division of radicals, and you need to have the index has to be the same. And you just go ahead and multiply and divide. When you're adding and subtracting, you have to make sure, the rule is a little different, that when you're adding and subtracting, the index has to be the same. So they both have to be cube root, square root, fourth root, fifth root, so on. And the radicand, the number underneath, has to be the same. So the index has to be the same and the radicand has to be the same. When this happens, what you do, so let's say I have 6 and let's put a 2 here. If the index and the radicand is the same, all you do is combine, do whatever operation, whether it's adding and subtracting, you're going to add 6 plus 2 to get 8. And what you do is you're going to keep the index and the radicand the same. So it's kind of like, what's 6x plus 2x? It's 8x. So you're going to keep the cube root, keep these two the same. You're not adding or subtracting the index or the radicand. So your first example is, what is 5 root 2x plus 9 root 2x? Because the indexes are the same and the radicand is the same, all you're going to do is add 5 plus 4, which is 14, and you're going to keep root 2x. For B is asking you to add and subtract. It says 3 cube root 10 plus 7 cube root 10 minus 5 cube root 10. Because these are all cube root 10, you can add 3 plus 7, which is 10, and 10 minus 5 is 5, and it would all be cube root 10. Very simple. Okay, so let's do a few more of these examples to make sure we have it down. For number 3, it's square root 13y, square root 13y, because these are the same. 9 plus 4 is 13, and then square root 13y. For number 4, we've got fourth root 5, fourth root 5, fourth root 5. Now there's an understood 1 in front of here. So we're going to add 1 plus 9, which is 10, and 10 minus 3, which is 7, fourth root 5. Okay? Now, what do you do when they're asking you to add or subtract, but notice how what's underneath the radical sign is not the same. The indexes are the same, but so you can't add the 12 and the 3. So what you have to do is you're going to individually simplify these. Now 7 root 3, that can't be simplified, but 12, based on the last section, is 2 times 2 times 3. So we can take this 2 out, multiply it by that 3, you get 6, and you're going to leave square root of 3 here. And now, because these are the same, 6 plus 7 is 13, and keep it as square root of 3. For B, it has 3x square root of 20. 20 has to be broken down into 2, 2, 5. We could take that 2 out, multiply it with this 3x, so you get 6x root 5x. That's simplified. Minus 7, 5x cubed, square root of that. So we can take out an x here. So this becomes 7x square root 5x. Now, because these are the same, you keep them as root 5x, and 6x minus 7x is negative 1x, and then square root 5x. And letter C, I can't simplify square root of 5, and I can't simplify that. So this one is already simplified. There's nothing you can do. Let's do a few more of these. Number 5 here. 4 times the square root of 18. Well, we can take 18. 18 is 2 times 3 times 3. Take that 3 out. 3 times 4 is 12. Square root of 2. Minus 3 root 8 is 2, 2, 2. Take that 2, take a 2 out, and that'd be 6 root 2. And then 12 minus 6 is 6. Keep it as square root of 2. Number 6. Negative 5x. I'm looking for 3 of a kind. 27 times 2, so 2, 3, 3, 3, and x. I can take these 3's out. So this 3 multiplies with that to give you negative 15x. But cube root of x stays. And then we have 7 cube root 2. We have 3 x's that we can take out, but 1 has to stay. So this becomes 7x cube root, I forgot the 2 here. So this becomes 2x. So that was an indicator that I had 2x here. I missed that 2. So now these are the same. Negative 15 plus 7 is negative 8x, and then cube root 2x. And number 7 is fully simplified because I can't break down that 10 or that 3, and they're not the same, so I can't add 10 or subtract, actually. Can't do any subtraction at all. Okay, example 3. We just have more of the same. So what happens now here is we have variables. So 3 cube root 16 is 2, 2, 2, 2. And then we have 4 x's. So I'm taking 3 of each of these. So you get 2x. And what's going to stay is cube root 2x. Minus. So we have 7x. This we can't do anything with. This is, we could take out the negative 1. This is negative 1 times 2. So the only thing you could do in this piece here is take out the negative. So this now, negative 1 comes out. So this is going to become plus 7x cube root 2x. And now we have 54. 54 is 2, 3, 3, 3, and an x. I take that 3 out. And I am going to leave cube root of 2x. Now, in this problem, I cannot, when I combine these two are like terms. This one's not. This doesn't have an x here. So 2x plus 7x is 9x cube root 2x. And then this would just be 3 cube root 2x. I cannot combine these two because this does not have an x. Just leave it like that. Okay? We're not going to do the factoring out right now. So B, we've got 3 times the 4th root of, we've got 4 m's here. M, N. So I'm going to take these 4 m's out. So this is 3m 4th root of n minus. Now I can't do anything with this. I don't have 8 of anything. So I'm going to leave this as minus 5m 8th root of n squared. Now, if I turn, this is something you can do. If I turn this into n to the 2/8 power, 2 over 8, this reduces to 1/4. So this can be simplified as the fourth root of n. So we have 5m, fourth root of n, and now I can simplify these two. You get negative 2m, fourth root of n. So if you turn this into a radical, 2 over 8, you can reduce it to 1/4. So that's another thing that we need to talk about more of in class. Okay, so we're going to leave those. Now let's talk about multiplication using the distributive property and FOILing. So when you have a problem like this, 2x plus 6, you distribute. So 2 times x is 2x, 2 times 6 is 12. Well, you're going to do the same with these radicals. So you're going to distribute. So what you have here, and simplify. So the square root of 5 times 3 minus 4 root 5. Square root of 3 times, square root of 5 times 3 is 3 root 5. Just write them and put the square root at the end. Minus, we're going to multiply these two. So it's minus 4. It's root 5 times root 5. And root 5 times root 5 is 5. So this is root 25, which is 5. 4 times, you have a pair of 5s. 4 times 5 is 20. So that's how that's going to be. Okay. And for B, you've got cube root of 2 times 3 plus cube root of 4. So cube root of 2 times 3 is 3 cube root 2. You're just multiplying these two. Put that number in front. And then cube root of 2 times the cube root of 4 is really the cube root of 8. Right? 2 times 4 is 8. You can multiply what's underneath here. And the cube root of 8, 2, 2, 2, that 2 comes out. And that's how you will do these problems. Okay, moving along. Now we're going to FOIL. First, outer, inner, last. Now, 3, you're going to do first. 3 times 2, let me write this out. 3 plus 2 root 7 times 2 minus 3 root 7. We're going to FOIL this. 2 times 3 is 6. 3 times, these are the outer, so first outer. 3 times negative 3 root 7 is negative 9 root 7. Then inner. 2 root 7 times 2 is 4 root 7. And this last one, 2 root 7 times negative 3 root 7. I'm going to write it off to the side here. 2 root 7 times negative 3 root 7. So 2 times negative 3 is negative 6. And root 7 times root 7 is 7. So this ends up being negative 42. Again, let me go over it. These two multiplied give you negative 6. And negative root 7 times root 7 is 7. Negative 6 times 7 is negative 42. Now these two get added together because they are like terms. So you have 6. This becomes negative 5 root 7. And you've got minus 42. You can combine these two. So 42 minus 6 would be 36, and it'd be a negative. So negative 36 minus 5 root 7. So these two combine, these are like terms, you get negative 36, and bring down your negative 5 root 7. Moving along, let's do a few more of these. So let's do some more simplifying. So root 6 times 3 is 3 root 6 minus root 6 times 5 root 6 is, it's root 6 times 5 root 6. These 6's come out, so it's 6 times 5, which is 30. So it's 3 root 6 minus 30. Number 11, we're going to distribute. So this would be 3 times the cube root of 12 minus that times that would be cube root of 24. 12 times 2 is 24. Now, if we break these up, I can't get 3 of anything here because this is 2 times 2 times 2 times 2 times 3. But this 24 is 2, 2, 2, 3. I can pull a 2 out and leave cube root of 3. So this is not very nice looking, but that's the way that is. And then for 12, you're going to distribute, FOIL, whatever method you use, whatever you call it, FOIL. Some call it the distributive property, so you're multiplying 2 times both of these, and then negative 7 root 3 times both of these. So 2 times 5 is 10. 2 times 4 root 3 is 8 root 3. Negative 7 root 3 times 5 is negative 35 root 3. And then this times this is, we're going to write it over here, negative 7 root 3 times 4 root 3. Negative 7 times 4 is negative 28, and then we have 2 3's here. Okay, so 28 times 3, so that's 24, 84. So this is negative 84. So that times that is negative 84. And when you combine like terms, these two are alike, and you get negative 27 root 3. And 10 minus 84 is negative 74. So there's your answer. Okay, and I believe this is going to be the last section, and it's special products. This is saying take 2 root 3 plus 5 and square it. So you have 2 of them. You're multiplying 2 root 3 plus root 5 times itself. So here we go. 2 root 3 plus root 5. You've got 2 of them. 2 root 3 plus root 5. So we've got this times this. So we're going to do this. 2 times 2 is 4. And then we have one of these 3's. So 4 times 3 is 12. Then we've got 2 root 3 times root 5. So that would be 2 root 15. And we have another one of them. So there's going to be really 4 root 15s. This and this multiplied, you get 2 root 15. And then root 5 times root 5 is just plain old 5 because it's root 25. So now these two get added together, 4 root 15, and 12 and 5 is 17. Okay, and B. What you're going to notice about B is a nice one. These are called conjugates. When you have a binomial and, well, 2 terms, we'll say, 2 terms, and the signs are opposite, those are called conjugates of each other. So you don't have to FOIL this. You can just do first and last, because the two the outer and the inners will cancel out. But we're going to do it anyway. 3 times 3 is 9. 3 times negative root 7 is negative 3 root 7. And then 3 times root 7 is positive 3 root 7. See, these will cancel. And then root 7 times root 7 is 7, but it's a negative times a positive. So now these two cancel out, and 9 minus 7 is 2. We're going to do a couple more, and we are done. So for 16, we've got 2 minus root 5. We're squaring it. So we have 2 of them. So 2 times 2 is 4. We have 2 times negative root 5, which is negative 2 root 5, and another 1. And then root 5 times root 5 is 5, and it's a positive because a negative times a negative is a positive. So 5 plus 4 is 9, and then minus 4 root 5, because these two are alike. 17, we have root 7 plus 3 root 2, but we have 2 of them. So root 7 times root 7 is root 49, which is 7. Root 7 times 3 root 2 is 3 root 14. 7 times 2 is 14. And we have another one of them, 3 root 14. And then here's the last one. 3 root 2 times 3 root 2. 3 times 3 is 9, times 2 is 18. 7 and 18 is 25. 3 root 14 plus 3 root 14 is 6 root 14. And that's your answer. And the last one. Okay, these are conjugates. So all you have to do is root 3 times root 3, which is 3. And then the next two will cancel out. You get root 6 minus root 6, which is 0. And then root 2 times root 2 is 2, but if there's a minus sign, because a positive times a negative is a negative, and your final answer is 1. The end.